Welcome to Structural Engineering Online. In this video lecture, we will learn how to calculate support reactions of a simply supported beam. Please subscribe to our channel if you have not yet subscribed, so that in future you will get the notifications of new video lectures. Thank you. In this question, we will calculate the support reactions of a simply supported beam which is subjected to a uniformly distributed load and a point load. So in this question, the uniformly distributed load is not on the entire length of the beam. It is only on a small portion of the beam, which is 2 meter length. First of all, we will see how many reactions are possible on this beam. So support reactions, as we know that a hinge support will have how many reactions? 2 reactions. So we say, okay, 1 horizontal and 1 vertical. At B, we will have only 1 vertical VB. So this way, we have shown the reactions acting on the supports of this beam. Now, first step in calculation of the support reactions is to apply the equations of equilibrium. So when we solve for the reactions, we start with the equations of equilibrium. First, sigma fx equal to 0, which is saying that algebraic sum of all the forces in x direction should be equal to 0 for the equilibrium of the beam. So from here we find that there is no applied load on the structure, and our assumed reaction HA definitely will become 0. Okay. So in the beginning we have assumed these reactions in the positive directions. So our positive directions in x direction right hand and y direction positive up, and anti-clockwise moment is positive. So these are the sign conventions which we are using in this calculation. Now our second equation is sigma fy equal to 0, and in this case now we have these two reactions VA and VB which are acting in the upward direction. So we say here plus VA plus VB. Then the forces which are acting on this beam, there is 2 kilonewton load acting downward. So downward force is taken as negative, so 2. Then UDL is for 2 meter length and it is 2 kilonewton per meter. So total UDL is 2 into 2. And there is no other load acting on this beam. So this total sigma Fy is 0. So from here we can say that VA plus VB will be equal to 6. This is our first equation which shows the relation between VA and VB, that the sum of these two reactions will be equal to 6. Now we go to the third equation of static equilibrium, sigma m equal to 0, and here we take the moment about point A, and in that case we have this moment of HA and VA equal to 0 because these two forces are acting at the same point A, so they will not give you any moment. Then we go to take the moment of this VB. So VB into the distance from point A, 1, 2, 4, 5. So VB into 5. And according to our sign convention, this is anti-clockwise, so it will be positive moment. Then we take the moment of this 2 kilonewton force, and this 2 kilonewton, if we look here, it will try to rotate the beam about point A in a clockwise direction. So clockwise is negative, we take minus 2 into the distance from point A, 1 plus 2, 3, 3 plus 1, 4. Then we take the moment of this 2 kilonewton per meter UDL, because this UDL is for a length of 2 meters. So total UDL is 2 into 2. This is the load. Now we multiply by the distance of its centroid from point A. So in the case of UDL, we have to take the center of the UDL, and from that we have to take the distance, which is half of 2 and 1 meter from A. So this total will be 1 plus 1, that is 2. So multiplied by 1 plus 1, half length of the UDL plus the distance from A to the starting point of UDL, and this whole thing equal to 0 because there is no other moment. So we get the value of this VB from here. We can say 5 VB, and then minus 8 equal to 0. Therefore we get VB equal to 16 upon 5. Once we get the value of VB, we can easily calculate VA. So VA is 6 minus 16 upon 5, because VA plus VB is 6. So we substitute the value of VB in that equation here, in this equation, and we get the value of VA, 6 minus 16 upon 5, and that will be equal to 14 upon 5. So with this calculation, we get the value of these support reactions at A and B of this simply supported beam, which is having point load and UDL. I hope this lecture has helped you in learning how to calculate the support reactions of simply supported beam. So if you like this video, please share it with your friends so that they can also get the benefit of this video lecture, and please subscribe to our channel so that in future when we post any new video lecture, you will get the notification. Thank you very much.